Yeah, good afternoon, everyone. My name's Tom Llewellyn. I'm a sales engineer at Sysdig. But prior to that, I spent about 10 years on and off at Red Hat, and my final role at Red Hat before I joined Sysdig was as an OpenShift architect. And one of the main reasons why I chose to join Sysdig was some of the issues that I was seeing as I was trying to resolve problems for customers of OpenShift as they move their workloads into production and start getting more and more complex operations on the platform. That the sort of complexity that introduces. When I saw what Sysdig does and how it works, there was a sort of penny drop moment of course, yeah, this is how you should do it. And so what Sysdig is doing is effectively, for these container platforms, is actually building this intelligence platform based off an open source tool set that you see there. So things like Prometheus, Sysdig Inspect, Falco, the policy enforcement engine, Anchor for scanning images. We pull all that together and then build this intelligence platform that actually helps you to make sense of the dynamic environment and the complex environment of a microservices architecture, so that you can then actually properly, A, observe what's happening, and B, secure what's going on inside, and be assured and gain confidence in what's happening on the platform. So the way that works in terms of the commercial product, we have this platform that presents this both from a monitoring and a security perspective. But what I thought I would do today in just a 5-minute talk would be sort of concentrate in on one aspect of one of the things that we can do. So the Falco security engine. So this is now a cloud native computing, so it's a CNCF incubator project. So we've actually donated that to them. It's now becoming the de facto way of implementing runtime security on containers. And just work through an example of how we use that in the product to enforce runtime security. So just to give you an overview of how Sysdig works as a platform, essentially on OpenShift we would deploy as a daemon set, and that daemon set deploys a privileged container to each node in the cluster, and then that daemon, that container will start instrumenting the kernel. So we are pulling an event stream from the kernel on the host, which means that we see every system call that happens on that host, and from that we can then build a picture of what is happening. So when we give you a metric of, the network latency of a connection, that's because we've actually measured, we've seen the read and the corresponding write, and we've measured the time between them, so we're actually generating real-time information. And from a security perspective, that means that also nothing can happen inside a container without us seeing it, because everything that you do in the container is also making a system call to that one kernel because of how containers work. So that gives us this rich source of information and also the ability to spot anomalies in behavior and enforce that behavior as well. So we can actually do two things. We can alert you when suspected breaches happen, but we can also stop the container or pause it, so so it gives you this enforcement ability as well. So switching to a quick view of how that looks in practice. So on the right, you'll see the actual YAML syntax for a Falco rule, how that appears in the GUI that we give you on the web. So these are just two views of the same thing, effectively. So this particular example is somebody has managed to start an interactive terminal shell inside a container. That might be in your dev environment perfectly acceptable, but in a production environment, it's viewed as suspicious activity. This could be, for example, somebody's managed to actually breach your code and buffer overflow or something drop to a shell prompt. And so we have this is a real world example of the sort of attacks that can happen. And when this happens, we can actually then do two things. We can notify you that it's happened, so through whatever channels you define. We can also stop or pause the container, but we can also, which is a unique feature to Sysdig as well, activate a capture. And what this is essentially a time-based complete dump of all system activity on the host where this container is running for the time that we define. And you can see here that in this example, we can also start from before the event triggered as well, because we're maintaining a ring buffer of that system information. So we can get the events leading up to the trigger and then a time period afterwards, so you can see what happened. And then that capture file can then be uploaded to the back end or downloaded to wherever you want to. And you can run another tool called Sysdig Inspect, which allows you to then analyze that information. So this is the Sysdig Inspect interface. You can run it on the web, you can run it on your laptop, and you can see that this then gives you quite a bit of information about, this is the full dump of everything that happened on that system in that 30 seconds. So what you can then do with this is you can start clicking on the individual boxes, and as you do so, it populates the timeline at the bottom, and you can then narrow it down into looking at specific portions of that time frame. So as you drag onto that timeline at the bottom, you can actually drill in and look at specific bits of what's happened in that capture. And so for this one here, we know that it's a terminal shell in a container, so drilling down to see when the alert happened and then looking at, well, there was a bunch of commands that ran after that and a load of files got deleted. So we can then start to analyze, well, what was going on? What was that person doing, that attack that happened? And if I clicked onto the executed commands tab, what it will do is drop me into this view, which actually then just gives me a list of the commands that have been run by that shell script. And so you can see exactly what's happened there. And this entire attack took place in less than a second. And what they've done is they've dropped to a shell prompt, downloaded some content that was base64 encoded, deleted a directory in the container, replaced it with their own version, and then dropped the connection. So had you not had something like this enforcing, that attack could have happened. You'd be none the wiser. It's still there running in your environment. So in terms of the richness that this gives you and the ability to detect anomalous behavior and enforce it in production, there's nothing else out there that works in this way. So if you'd like to know more, come and see us on table 7 out in the back hall, or you can reach me. My contact details are at the beginning of the slide. Be happy to talk to you more about it. Thank you very much.
Perfect.